In this lecture, you'll learn about SNMP, which is the Simple Network Management Protocol. It's an open standard for network monitoring, and you'll see it being used on nearly all vendors' devices, not just routers and switches, servers, everything else as well. The terminology for SNMP: there is an SNMP manager, which is the SNMP server, and it can collect and organize information from an SNMP agent, which is SNMP software, which runs on managed devices such as routers and switches. So that's the official terminology, but real world, you won't hear people talking about SNMP manager and SNMP agent. The manager will be called an SNMP server, or an NMS system is commonly used, which is Network Management System, and the managed device is just an SNMP managed device. The SNMP manager, the server, can pull information from the device with a GET command, or the device can push it to the server with a trap. So for example, the manager could query to get traffic statistics from the device, or the device could report an HSRP state change. For example, if one of the routers in an HSRP pair went down, the router could push a notification, push a trap to the NMS server about that. The standard also includes support for modifying agent information from the SNMP manager to change device behavior, but that's not used so commonly. So most often the NMS server will pull information from the devices, or the devices will send a trap to notify the SNMP manager that something happened. There is an MIB is used as the database for the information. Data variables on SNMP managed systems, for example, the state of an interface, or the state of OSPF or RIP, etc., those variables are organized into an MIB, the Management Information Base, which is the database of things that you can gather information about on your different devices. The SNMP manager and agent need to share the MIB so they know which variables can be reported on. And different types of devices will have different MIBs, because the kind of information you would want to gather from a Windows server would be different than the type of information you would gather from a router or a switch. So this diagram shows the architecture. We've got the SNMP manager, which is our NMS server, and in the example, there's a couple of managed devices, and they're both running the SNMP agent software. So we've got a switch and a router. They've got MIB, which includes variables that are relevant to that type of device. The SNMP manager understands the MIB as well, and the SNMP manager can send queries to the devices to gather information from them. The devices can also send trap notifications to notify the SNMP manager that something happened. Also, you've got that third option where the SNMP manager can actually push and change information on the devices, not used as commonly. With the SNMP versions, there's been 3 major versions. The first version was SNMP version 1. That uses plain text authentication between the manager and the agent. So the authentication is not encrypted. Anybody can read it if they're sniffing that traffic. The method that is used for the authentication is community strings, which act like a password. SNMP version 2C also uses plain text community strings for the authentication. The main advantage of version 2C over version 1 is that it supports bulk retrieval. So rather than having to send a new message for every piece of information it wants to get, it can send a request for multiple pieces of information at the same time. Makes it more efficient. And the latest version is SNMP version 3. It does support strong authentication and encryption with the use of usernames and passwords. It is the preferred version because it is secure, but it's not supported on all devices. You'll find a lot of devices that are still out there today don't have support for SNMP version 3 yet. So in that case, you would have to use SNMP version 2C if you did want to enable SNMP. So talking about the authentication in version 1 and version 2C, it uses community strings rather than the normal username and password that you're used to. So the community string is used to authenticate the SNMP manager and the agent to each other. It acts just like a password, and the same community string value has to be set on both the agent and the manager. That's how they authenticate to each other. There is both read-only and read-write community strings. The read-only community is used by the manager to read information, and the read-write community is used if it wants to set information. So here's a configuration example, and for the CCNA exam, this is the same with Syslog as well. You don't need to know how to set up the Syslog server or the SNMP server, because there's lots of different vendors that offer software products for that. That's obviously out of scope for the exam. The exam is testing you on how to configure the Cisco router and switches, not any external software. So this is how we would configure the configuration on a router for SNMP v2. First up, we say it global config, SNMP server contact, neil@flackbox.com, my email address. Then SNMP server location, FLACKBOX'S lab. So that's just purely informational, and it's optional if you want to set that. But your SNMP server is going to be monitoring lots of different devices, so it's good if you've got some descriptive information about the device that will be sent to the manager. Next part of the config is our community strings, which are used for the authentication. And we're configuring both a read-only and a read-write community string. We've got SNMP server community FLACKBOX1, which is we're using as our read-only string, and SNMP server community FLACKBOX2, which we're going to use as the read-write string. Then we need to configure where our SNMP server is. So we say SNMP server host 10.0.0.100 is where the server is. And for communicating with that server, when we're sending traps, we're going to use our read-only community string, which was FLACKBOX1. Then we put in a command to actually send traps to that server. This is optional. If we did not have the SNMP server enable traps config command, the server would still be able to query this router to pull information from it. But because we're configuring traps, we're also going to push information to the server as well. You'll see when we do the lab demo that there's lots of different types of traps that you can send. So you can send information about a change in the OSPF state, a change in the state of an interface, etc. Here we're doing traps config, which means whenever anybody else goes to global configuration by entering the config t command, it's going to send a notification about that to the server. Okay, last thing to tell you here is some SNMP security best practice. We said before that SNMP is an open standard. It's supported by nearly all vendors' devices. Most devices will use a default read-only community string of public and a default read-write community string of private. And attackers can use this to read or set information on your devices. If an attacker has got IP connectivity to the device and it's been set up with SNMP enabled using the default community strings of public and private, then the attacker can use that to pull information about the device. There's likely to be sensitive information there that they can then use to launch an attack against your devices. So you do not want to leave that as the default setting. Best practice is to disable SNMP on devices if it's not being used. And if you do want to use SNMP version 3 with secure passwords, because that is a secure way of implementing it. However, quite likely you will have devices that do not support version 3. So in that case, use SNMP version 2C, but use non-default community strings. Don't use public and private. In the earlier lectures in this section, you've learned about Syslog and SNMP, which are both used for logging. And you've also heard about SIEM systems and NMS systems as well. And you're probably thinking, well, aren't these things all doing the same thing? Do I have to choose one or the other, or what do I do? So I'm going to clear that up for you in this lecture. First up, comparing Syslog and SNMP. And both Syslog and SNMP provide logging functionality. Syslog can often provide more granular detail than SNMP can, but it has support only for the device pushing information out to a Syslog server. It doesn't support a server pooling or setting information onto the device like you can do with SNMP. So Syslog, a bit more granularity on the amount of reporting it can do, but SNMP has got a bit more functionality there. So do you have to choose one or the other? Well, no, NMS servers will typically support both Syslog and SNMP. You see the diagram I've got on the slide here. That's from the Kiwi website, which was the software I was using for the demo earlier. And you see that the Kiwi server, it's marketed as a Syslog server, but it supports SNMP as well. It also supports other types of events coming in, for example, from the Windows event log. And this is typical. An NMS system will usually support getting information from multiple sources, both Syslog and SNMP, and other sources as well, including NetFlow from Cisco routers. So you don't have to choose one or the other, you can run both, and you can use them where they fit best. Next thing is NMS and SIEM, because we talked about both of those earlier as well. The NMS is your network management system. The SIEM is your security information and events manager. And just like there's overlap with Syslog and SNMP, which are the protocols that are used, there's also overlap between NMS and SIEM systems, which are the servers that are used to monitor all this information. So with NMS and SIEM, both can gather logging information from network infrastructure devices, such as routers, switches, and firewalls, also from other devices as well, like servers, and that uses protocols like Syslog, SNMP, and NetFlow is commonly used to send networking information from Cisco routers. So what's the difference between NMS and SIEM? They're both gathering that information. Well, a product which is marketed as an NMS, which is a network management system, will have a focus on collating network information, and it will provide nice reports and a nice GUI so you can see what's going on with your network. It will provide early warning of any problems and easier troubleshooting of those problems as well. A product which is marketed as a SIEM, as a security manager, will have a focus on collating security information, and it will provide reports which focus on that, and early warning of any security incidents and easier troubleshooting of them. So they can both gather the same kind of information, but they've got a different focus on how they're going to report it and the tools that you can use to manage it. So let's have a look at an example of that. Looking at an NMS system here, this is from SolarWinds, who are a very popular paid NMS. And you can see here it's got nice GUI, you can get nice graphical reports. And over on the right, you can see the kind of information that is being highlighted, interfaces with high % utilization. So if you've got interfaces that are getting congested, it's going to tell you about that. So you can fix it by putting more bandwidth in there, or maybe by configuring QoS, quality of service, that we're going to cover later on. Also down at the bottom, it's reporting on interfaces with high error and discard rates. So it's giving you a nice dashboard where you can see everything that's going on in your network, and it's also highlighting any potential network problems. If we look at a SIEM, on the other hand, this is from InfoSite, it can get the same kind of information, but you see that it's focusing on different types of reports. It's telling us the top 10 event categories. So we can see that the most common fault we have is authentication, meaning people are putting in the wrong password. That's normal for that to be high, because people do sometimes put in the wrong password. But if you see that that is unusually high and there's been a jump in it, that could indicate that an attacker is trying to break into your systems by guessing your passwords. Further down, we can see that the next most common thing is malware attacks against us. We can see other exploits in there as well. Other kind of information, we can see which are the most common attacks that are being launched against this. Also, which hosts have been receiving multiple events. So if we're a security engineer, we're going to come in the morning, we're going to look at this dashboard, and maybe one of the first things we'll do is we'll go and we'll investigate these hosts to see if there's anything bad happening with them. Okay, so that's the difference between an NMS and a SIEM. Thanks for watching. If you want to get hands-on practice with Cisco networks for free, then you can download my 400-page CCNA Lab Guide, which you can see above my head right now. Also, check out the video about my CCNA course. It's the highest rated course online. Thanks.